Alright, so welcome again to Introduction to Economics. A few explanations. What's gonna happen here is that we're gonna talk about some concepts, and this is part of the lectures. So the way it works is that every week you watch some video like this one, where you're given notes, and you have to take down the material in your notebook. This is part of the learning process. So you get the concepts and definitions here, then you have some questions. So there are some questions in the slides where you have to answer, and then there are also some questions on Moodle. Alright, so this is for your practice, just to make sure you understand things and you can apply them. The next day when you come to class, you're going to be given some practice in class. Usually you do them in teams. So you solve some problems, and I give you some short lecture also in the class. Okay, so the class is divided into these videos and also the class time that you work. Alright, the more practice you do, the better you learn. Part of your learning is to take good notes. The simple rule is this: whatever you see on the screen should go in your notes. So just copy down anything that you see in the screen. What I suggest is that as you watch the movie or the video, pause whenever you want, whenever you think is appropriate, and write down what is on the screen, then move on to the next part. Okay? Another suggestion is that you see the slide number in the corner, on the top right corner. Write down the slide number because it helps you for future reference. So whenever you will move to a new slide, write down the slide number, then write down the notes in there. Okay, so feel free to pause, go back and forth, and make sure you got down everything. Sometimes I ask you to come and show me your notebooks for participation points, so that's also an incentive for you. Also, if you notice that I emphasize something or you repeat something, you might want to write that down also. So listen carefully. If you see that I'm emphasizing something, it means that it's a common mistake by students. All right. So in this first lecture, we're going to talk about an important concept, which is opportunity cost. So opportunity cost can be defined as the next best alternative that is sacrificed when you make a choice. It is what you give up in order to obtain something. It's an opportunity lost, or a foregone alternative. So these are different terms for the same concept. So an important term here is sacrificed. So when you write it down, underline it or highlight it, and also give up. That's the essence of opportunity cost. It's something that you sacrifice, something that you give up. So let's look at an example. Let's say you want to buy a bike and you start saving, let's say $800 for the bike. Now the opportunity cost of the bike is something else that you could buy with that with the $800. Alright, so for example, let's say you could upgrade your cell phone to a better one or a newer one. The other choice, which is the cell phone, is your opportunity cost. You have to give up the cell phone in order to get the bike. You could have got the cell phone, but you chose to get the bike. Alright? If you choose the cell phone, the opportunity cost is the bike because you are giving up the choice to get the bike. So let's look at another example. Again, as we go through these slides, make sure you pause at the right time that is fit for you to take notes. Whatever is on the slides, you should copy down in your notes. Alright, so you have to pause at the end of every slide before moving on to the next. So this is a good example. Suppose the government decides to build a hospital which costs $5 billion. What is the opportunity cost of this hospital? Now, one thing to watch out is when you want to make a hospital for $5 billion, the immediate answer is, oh, $5 billion, that's the cost. But that's not the opportunity cost. Okay, so that's an important point. You might want to write this down, that the dollar value is not the opportunity cost. Okay, so that's not the answer. You have to think about alternatives. Okay, you have to think about other possible options and choices. What else could the government do with the $5 billion? Remember that bridge which is falling apart? What a mess. So maybe they could fix that bridge. Yeah? So fixing Champlain Bridge could be an alternative to the hospital. If they want to build a hospital, they have to let go of that fixing of the bridge. Or lower student fees. So maybe instead of building the hospital, they could invest that money in education, right? So you have to think about the government's different options, and that would give you the opportunity cost. All right, again, time to pause, take down some notes. All right, so continuing with opportunity cost. There are more costs to doing something than the price that you pay for it. All right, so whenever you think about opportunity cost, it's not just the price. It's not just the money that you take out of your pocket. You have to think about what you have to give up instead. So the alternatives, other possibilities. There is always an opportunity cost as long as we have two conditions. One, as long as we have limited resources. Remember the four resources? And two, as long as there are more than one option for how to use your limited resources. So these are usually there, which means that we almost always have an opportunity cost. We're always dealing with some limited resource, and we usually have more than one option, right? So we have to pick and choose. Yeah, you have to take one and leave the other. So that's why opportunity cost is very practical. So you might want to highlight or underline that word. There is always that opportunity cost. Whenever you choose anything, you also lose something. Not that you take it out of your pocket and lose it, but you lose the opportunity of it. Alright, so that's an interesting picture where you're dealing with two doors. You can only go through one of them. And the neat thing with economics is that it's being very conscious about these things. So learning about these trade-offs and trying to choose the best alternative. So that's really the point of economics. The next topic is production possibilities. So we're moving on to another concept. So you might want to write a new heading. Also record the slide number where you have the slide number up there in the corner so that you'll have it for future reference. So production possibilities are about how much of a good or service a society can produce given its resources. Okay, GS stands for goods and services. An important concept here is how much we can produce. It is our production capacity. So that's also an important term here that highlights the theme of production possibilities, how much we can produce based on our resources. So let's look at a very simple example to illustrate this. Suppose we have a simple economy that produces only two goods, either cars or corn. And also suppose that if we use all of our resources to make corn, we can make 15 corns. Now I just dropped the units for simplicity. Alright, so you can think of kilograms or bushels or whatever. Now think of this scenario. We are using all of our resources to make corn, and we can make 15 corns. How many cars are we producing at this point? If you're using all of our resources for corn, then it must be that we're making no cars. right? Because we don't have any resources left for cars. Again, time to pause, think about your 4 resources. You should remember them. If not, refer back to your notes. You need to know the 4 types of resources: land, labor, capital, entrepreneurship. Yeah, so that's what we're talking about here. Now, can we make a car? And if so, how can we make a car? So if you think of it, we need resources to make a car, but all of the resources are being used in corn production. Okay, so if we need to make a car, we have to get rid of some of these resources which are in corn production and put them into cars. So we should reduce our corn production so that we free up some resources to make a car. Okay, and that's where we have the concept of trade-off. Yeah, so this should ring a bell. What is it called when you give up something to get something else? You have to give up corn to get car. Yeah, remember that? It's opportunity cost. So that's what we're dealing with here. So suppose we can make 12 corns and 1 car. So if we reduce our corn production by 3 units, it frees up enough resources to make a car. Alright, so it's about freeing up resources. Or we can make more cars by reducing corn even more. So let's say if we reduce our corn to 9, then we can make 2 cars. Yeah? So the next question is, what about 3 cars? Can we make 3 cars? Well, same logic. You need more resources, so we have to take it out from corn production. So we can make 6 corns and 3 cars. So I'm making the numbers very simple, but it could be any other numbers as long as it goes in the same direction. Or we can make 4 cars by making 3 corns. So we are reducing corns more and more. It frees up more resources, and we can make more cars. Can we make 5 cars? Yes, by making no corns. Yeah. So if you think of it, this point where you are making 0 corn is really the opposite of the initial point where you are making 0 cars. The difference is the similarity is that all of the resources are in one place only. The difference is where it is. Okay. The next question is, can you make 6 cars? If you think of it, no, because we don't have any more resources. Yeah, so this is about how much we can produce based on our resources. We can make 15 corns and no cars. We can make no corns and 5 cars, or we can make the combinations in between. We are going to take the same values and numbers and put them in a table. Okay, so in your notes, draw a table just like the one you see on the screen with the same number of rows and columns. The last column, we keep it empty for now. We're going to fill it later, but leave some room for yourself. Okay, so make a column for point, for car, for corn, and then we're going to fill the number simply with the points that we had. So for instance, the first point is where we are making no car, but 15 corn. Point B would be where we had 1 car and 12 corn. Point C is 2 and 9, 3 and 6, 4 and 3, 5 and 0. Okay, so copy this table down. Then we are going to take these points and plot them on a graph. So draw a grid for yourself. If you can use a ruler, it's good. It's going to be more accurate. If not, try your best to make it as accurate and neat as possible. You don't want to make it messy. Try to make it large so that you don't cram stuff in there. Alright, So on one axis we have car, so let's put that on the x-axis or the horizontal axis, and on the other axis we have corn, so that would be the vertical axis. And these are the two products that we're making, so we have a simple economy, and you make the numbers based on the numbers that we had. So if you look at point A, it's a point where we had 0 car and 15 corn, so that would be point A. Then point B is where you have 12 corn and 1 car. So put a dot for each of them and write the letter next to it, just exactly as you see it on the screen. And we have the rest of the points following along. Once you plot the points, you can simply connect them to get a straight line. Okay. If you can use color, do that. Make it neat, make your notes understandable for yourself. You're going to come back to it later. In this case, we have a straight line, but not always. Sometimes it won't be a straight line. It depends really on the numbers that you have. And this line is what we call a PPC, Production Possibilities Curve. The PPC stands for Production Possibilities Curve, so write that down. And the definition of the PPC is a graph showing all combinations of goods and services that can be produced given two things. Given all resources are fully employed, employed means used, we are using all of the resources, and a constant level of technology. So we're stuck with a specific level of technology, and at that level of technology, how much can we produce? Sometimes it's called PPF, and sometimes PPB, depending on the resource or the textbook or the website that you refer to. These are really all the same thing. PPF is Production Possibilities Frontier, and PPB is the Production Possibilities Boundary. Alright, so write those down, pause. If you forgot to take notes on the previous slides, also go back and make sure you have complete notes. As before, it's also a good idea to write down the slide number wherever you take notes, so that you have it for future reference. So let's go back to our table and complete it. So we are going to title our last column Opportunity Cost. And if you remember, opportunity cost is what you give up in order to get something. So let's start from point A. If you're at point A, we are making no car and 15 corns. And suppose we want to move from A to B, where we are making 1 car and 12 corns. So the question to ask is, what do we gain and what do we lose? So when we go from A to B, we're gaining 1 car, and we are losing 3 corns. So the opportunity cost is what we lose, which is 3 corns. So write that down in your table, and make sure you write the corns also, because you have to specify what it is that you're losing. So how much do we lose and what do we lose? Alright. You can also X out the first row because there is no comparison there. Whenever we talk about opportunity cost, we are making about a decision, a movement from one point to another. Now think of another step. Let's say we are at point B initially, and we want to move to C. What do we gain? Well, we gain 1 car. What do we lose? We lose 3 corns. Yeah? So in every step you have to compare that step to the previous step. Right? If we move from C to D, we're gaining 1 more car and we're losing 3 more corns. Yeah. From D to E again, we are losing 3 corns. And from E to F, again, we are losing 3 corns. Okay, so that's applying opportunity cost to the production possibilities. Let's go back to our curve and try to calculate the slope. You should have the formula for slope, so write down the formula first, which is, if you remember, y2 minus y1 over x2 minus x1, or rise over run, or delta y over delta x. So what you have to do is you have to plug in the coordinates of 2 points. And the neat thing here is that you have a linear curve, so you can pick any 2 points. So for instance, you can say, okay, let me pick A and B, and you can plug those in. Or you can say, I don't know, D and F. It's your choice. Plug in the X and Y values. So you can pause here and punch in the numbers and see what you get. If you do it right, you should get -3. Now, if you get a question like this in a test, you should be able to show everything. So you have to be able to start with the formula, and then you have to plug in your numbers, and then you get the final answer. So you have to show all of the steps in order to get full points. So make sure you understand how to do this. Now let's pause here. Does this -3 ring a bell? Have you seen it before? If you just go back to your table, you just calculated the opportunity cost from every step to the next one to be 3 units of corn. So this is something that we just learned, that the slope of the PPC is the same as the opportunity cost. So you might want to write that down, it's kind of important. The slope of the PPC equals opportunity cost. Now the difference here is that we have a negative here, and this should make sense because the line is going down, it's downhill, so the slope is negative. So that should be intuitive. We don't have a negative in the table because it says opportunity cost. When you say opportunity cost, it's already implied that it's negative. Now this is called constant opportunity cost. For every additional car, we have to sacrifice the same amount of corn. Every extra car costs the same units of corn. Alright? So, important terms here are additional and extra. We're talking about one extra car. One additional car. What is the cost of that? Okay, so pause there, take down some notes, and make sure you understand the formula and how it works. The constant opportunity cost that you just looked at is not very realistic. It's simple, it gives you a straight line, constant slope, but that's not usually the case. What we have usually is increasing opportunity cost, and that gives us a concave curve. So in your notebooks, draw a diagram and try to make it fairly large. You don't need to worry about numbers. Just write your car and corn on the axis just like before, but this time make it concave, as you see on the screen, and call it PPC. And like before, you can record the points on it. So you don't need to worry about any numbers here, just make sure the shape is right. The points on the PPC, which are points A to F, represent where all resources are fully employed. So on the curve, everything is fully employed. Employed means everything is being used. And that's where we have maximum possible production. And we are efficient. If you don't know what efficient means, you might want to write it down. Efficient means that we are not wasting anything. None of the resources are being wasted. Now record another point outside, let's call it G. The points that are above or beyond the PPC are impossible. So we cannot ever be located at point G. Why is that? You should know the answer to that based on what you've seen so far. So record your answer in your notebooks. I'm not gonna give it to you because it should be fairly obvious based on what you've seen. If you're undecided, come and see me. But this is also part of your notes. So write down the answer to that why. Let's look at another point H, which is inside the PPC. The points that are below or inside the PPC are possible. We can attain them, but some of the resources are idle. And idle means not working. So if you don't know what is idle, write that down. It means the resource is not being used. It's not working. It's just sitting around, not doing anything. This point H represents either of two things. Either the unemployment of resources. Unemployment means that something is not being used. It's not just about not having a job. It could be about any of the resources. Or inefficient, which means that all resources are being used, but not in the most productive way. So sometimes you're using what you have, but not in a wise manner. So you could do better. Either of those two will result in a suboptimal position like point H. So if you are told to draw unemployment, you can simply draw a PPC and put a dot inside, like point H here, and this would show unemployment. Inefficient is also an important term here, which means that we are not producing in the best way as we could. Okay, now this is a fairly useful and important concept, free lunch. So make another title for it. Let's assume that initially we are at point H. And starting from point H, we want to see what happens if we move to point B. Now think of it. When we move from H to B, are we making more corn? Yes, we're getting more corn. Are we making more cars? It's the same number of cars. It's not less, it's not more. Now what this means is that as we move from H to B, we are making more corn, but we are not losing cars. Usually when you make more of something, you lose other things. Remember opportunity cost? But in this case, we move from H to B, gaining something but not losing anything. Think of the move from H to E. It's kind of like the same. We are making more cars now without losing corn. So again, we are getting something for nothing. We're not losing anything, but we're gaining. Or we can move from H to either C or D. In this case, we're gaining both products. So we are making more corn and more car. So the common thing here, what's going on in this picture is that as we move from H to any point on the PPC, we are getting something for free. And that's the whole idea of free lunch. So write the definition for that. Free lunch means making additional units of a product without less of another good. It's when you have no opportunity cost. It's when you get something for nothing. And in this case, it's moving from point H to B, C, D, or E. There is no free lunch if all resources are fully employed. Now, if all resources are fully employed, it means that you are already on the PPC. You are on one of those points A, B, C, D, E, F. As long as you are on the PPC, you cannot get anything for free. You must give up something to get something else. But if you are inside the PPC, which means you are in a suboptimal position, then you could get something for free. Alright, again, time to pause, take down some notes. Alright, so here's another important concept in economics called growth. Um, in this picture, what you have is generic titles, goods and services. So instead of car and corn, we're just using something very generic. So copy this diagram in your notes, just as you see it. And we have point G, which is outside the PPC. And if you remember, it means that it's unattainable. It's just too much for us to gain it. So, economic growth means an increase in the economy's production capacity. It is when we can produce more goods and services. And the way you show this is that the PPC grows outwards. So what you have is you start with PPC 1, but then it can move outside. And then where does this come from? It can be a result of having more resources, better resources, or better technology. So these are the three main causes for economic growth. If we find more resources, if we have better resources, or if we have better technology, we can produce more. Okay, so the way you show this in a graph is, first of all, you draw arrows outward. So do this in your notebook. And then you draw a new PPC. In this case, it passes through G, which means that point G now becomes attainable. Remember to label your curves. So the first one is PPC 1, the second one is PPC 2. Alright, so you might want to pause here and make sure you have all of the notes and all of the diagram there. Just to clarify, what do we mean by more resources? More resources refers to the quantity or amount of resources. Better resources refers to the quality or the productivity of resources. So for instance, if the labor force, if the workers become more skilled, if they have more education and more experience, that's the quality of the labor. But more resources is just the number of workers that you have, or the amount of forests and natural resources that you have. And better technology means the knowledge of how to make use of our resources. So for instance, engineering, management, scientific formulas, new designs. So that would be, those would be examples of better technology. Any of these things would increase our production capacity. Again, time to pause, take down some notes.